Good morning, everyone, and thank you for joining us this morning. We have George Lennis and Don Hanser of Espar joining us today for a training webinar on Espar product. We would like to thank them for taking this opportunity. Espar has been a dropship program of ours for just over a year now, and they offer the eGuardian series heater solution and emission reduction items. And with that said, I would like to thank George and Don for joining us, and away with the webinar.
Well, thank you, Gina, and good morning, everyone. This is George Lennis with Espar Heater Systems. Thanks for joining us today. As Gina mentioned, we're going to walk over or go through the Espar eGuardian series of heaters on the Bluebird applications. The content for today's training, which would be in the next slide. Gina, you have to move over to the next slide. I don't.
It is.
Okay. This slide actually shows the content for the webinar. We're going to talk about heater specification, location of the heater, the content, the kit content description, a couple of words about the programmable timer, the multi-max timer, the electrical schematics, heater parts and operation, safety features, fault codes, diagnostics, annual pre-season maintenance, and warranty and technical resources. Slide number 3 will show us the specification for the OEM option. And we have the option code 013545-11, which is the Espar eGuardian 17,000 BTU fuel fire heater. It's available for all bus models. The main intent of this kit is basically to provide supplemental heat to the engine and thereby reduce engine wear. It also assists with the heater performance in cold climates. All of the kits come with an inertia switch, and later on in the presentation, I'm going to talk about the different styles of inertia switches we have recently introduced. Every heater has a normal operational range of 5,000 feet, but that can be extended with the help of a high-altitude sensor and thereby extend the operation up to 10,000 feet. On the right-hand side, you see the specification of the D5E unit. This is part of the OEM or the factory installed application. It has 3 stages, maximum stage being about 17,000 BTU. You can see the fuel consumption listed, and it says when you look at the values in that, you can see that it takes very little of fuel to run these heaters. These heaters come with an externally mounted fuel metering pump. We're going to talk about that later during the presentation. In terms of electrical draw, you're looking at a very low consumption rate, the maximum being about 3.3 amps while the heater is running. The coolant pump, the coolant pump which pushes the coolant through the heater, is an externally mounted pump, and again, it helps keeping the coolant through the heater, maintaining the flow rate so that the heater doesn't quickly cycle down. The D5E heater is one of a brand new style of heater that we have introduced into the market. It has a lot of unique features. It has a faster startup time. The components have been redesigned so as to avoid issues that we have earlier seen in the field as far as reducing the number of sensors, making sure that the heater is able to detect a fault event even before it happens and then shut down earlier as to protect the components, and just makes the heater much better suited to today's environment. What you're seeing in slide number 4 is the location of the heater. The box unit is chassis mounted on the left-hand side frame rail. It's located adjacent to the battery compartment, and you can see the box unit there on the slide as well as the internal components. The next slide, slide number 5, will give us a detailed view of what's inside the box. As you can see inside the box we have the heater, and in this case it's the Hydronic 2 D5E heater. We do have the coolant pump attached to the heater. It is sitting in the box. We do have the fuses and the inertia switches located inside the box. The inertia switch that you're looking at in this slide is the older style inertia switch. We do have a slide that comes up later that explains the new style inertia switch. We do have what's called as an electronic impact or inertia switch, which is even better. The old style inertia switch has to be manually reset by hand every time it trips. The electronic impact switch is automatically reset by the heater through the yellow wire when the heater is powered up. So it's even better. So the driver need not go and check the heater out or check the inertia switch before starting the heater. The purpose of the inertia switch is basically to open up the fuel pump circuit and stop the heater from operation in case of an accident or a rollover. But what happens mostly is when the bus goes over a curb or hits a pothole, or if it's driving on rough roads, sometimes the switch can get tripped. And then if the switch gets tripped, you have to go in and reset it. And if you don't reset it, the heater will not be able to operate because it will have a fault code 48 in the memory. Moving on to slide number, the next slide. What you're seeing over here is the Multimax F1000. This is the new switch that is included, that's going to be included in all the factory installs. Right now, as we speak, our team is working with your engineering group to introduce that into factory installed heaters. We do have the aftermarket kits available, which already come with this Multimax F1000 switch. This is going to replace your programmable timer. We do have a slide that explains the operation of the programmable timer, but this switch over here, right here, what you see is the brand new switch, redesigned totally from the ground up, and has a host of cool features. It has an LED indicator that will tell us if the heater has been enabled, whether it needs servicing, and even if there's a diagnostic fault code, it will blink, letting us know what those fault codes are. It comes with an SD card, which contains all the operating commands which are selected in the programmer. There is a software which is installed in the SD card, which allows you to program the timer, and it also maintains a log of the heater operations. The programmer can set the date and time, up to 4 events selectable on a 7-day week. You can have the heater turn on and off. You can also set a high temperature disable so that the heater doesn't run on hot days. You could also set a low voltage disable so that you can program what level of voltage you need the heater to shut down at. It has a selectable manual runtime limiter. There's only a single button, as you'll see on the slide. There's only one button on the switch that allows the heater to be run manually by the operator. But you can select or program the maximum runtime for that event. So every time the driver hits the button, the heater should run only for, let's say, 30 minutes example. So you can set the time. There is a preventative maintenance alert scheduler. After every 500 hours or 1,000 hours, it will alert you to the fact that you have to do preventative maintenance on the heater. There is a heater exerciser, which can be selectable based on your option as to you can, either tell it to give you an alert saying run the heater once a month, or it can do it automatically. It has an auto run feature, and then that can be set so that every month the heater will run. One of our most important maintenance recommendations for any kind of heater that we're talking about is run the heater once a month for 15 minutes, and that's the most important maintenance recommendation. Having the new Multimax helps us enable that feature or make sure that that gets done. The SD card also has an event log that will log every heater start time, stop times. In case of a fault code, it will log the fault code as well as when the fault event happened. This is really unique. The heater has an ability to store fault codes in its memory. But when you look up the memory in the heater, it will only give you the fault code, but it won't give you the date and time. The Multimax will give you the date and time when the event happened. seeing on the screen now is the new inertia switch. This is part of the aftermarket kit as we speak right now. As I mentioned, we are also moving forward to get this introduced into the OEM installation kits as well. The unique feature, as I briefly mentioned before, of the switches is automatically resettable. The heater on signal actually powers the device up, and the device will monitor to the X and Y axis, and if there's any kind of a shock, then the heater is turned off because the fuel pump circuit will be open. The output of the heater then will remain turned off until the heater has been restarted again. If there is an event which triggers the fuel pump output off, then the LED light on the device will stay lit, and that's an indicator for the technician or the maintenance that yes, this unit has tripped at this point in time. But when you try and restart the heater, it automatically repowers the device and resets it again. So it eliminates a lot of hassle out there in the field. It's part of the new kit. We move on to the next slide. Gina, if you can hear me.
Yeah, I can hear you.
I have lost I can't see the slides on my computer no more, so you'll have to let me know if the slide has come up on your screen.
Yeah, it's there.
Okay. What we're looking at is a fuel metering pump. It's, like I mentioned before, it's an external mounted fuel metering pump. It's a 12-volt pump. The way the fuel metering pump works is you have to supply it with 12-volt pulses, and that's what the ECU within the heater does. And for every 12-volt pulse, it basically clicks once. So by clicking or pulsing the pump at a certain frequency, the heater is able to deliver the exact amount of fuel into the ECU is able to deliver the exact amount of fuel into the heater. One of the main requirements of this fuel metering pump is the mounting angle, and that's shown on the slide. The minimum required mounting angle is 15 degrees. It can go all the way up to 35 degrees. When you buy a box kit, you can get this pump, which is externally mounted. It can be in the box. If it's mounted outside the box, it needs to be made sure that you have it installed at the right angle. If you don't install the fuel metering pump at the right angle, what happens? Then you could have cavitation issues. You could have overfueling issues, which in turn will result in overheating codes and carboning issues. We use a standard fuel pickup pipe with a 2mm plastic fuel line, which is used in the kit. And on the suction end of this pump, there is a fuel filter which we recommend that you inspect annually and replace if possible. That fuel filter is available as a spare part. When you looked at the specification of the heater in the earlier slide, you may have noticed that the fuel consumption rate is really, really very low. So the heater doesn't require a whole lot of fuel. But if you have a filter that is plugged because of dirt or debris or contamination in the fuel system, that little fuel flow will also be restricted, and in that case, the heater may not start, or if the heater is already operational, it may lose flame. Move on to the next slide.
It's there.
What you should be seeing now is the heater control timer. This timer is being phased out as we speak, but I do understand there could be a couple of buses out there which have these timers. The location is outside the electrical compartment just below the driver's window. And a couple of features of the timer, it has 8 on and off events, total 56 programmable events throughout the week. For every heater on event, you have to make sure you program an off event also. You can select a block of days. You could select 5 days a week or 6 days a week or even 7 days a week. And by doing a block programming, you can program the events and keep the programming short. Automatic activation is possible, and repetition of the programmed event is also possible using this timer. We move on to the next slide. And here what we see is a close-up view of the programmable timer. What you see on the display is the time, the programmed event, the day of the week indicator. The switch itself has, the timer itself has a couple of switches, a mode switch and a function switch. And at the bottom of the timer, we have buttons. We have a program button, we have a day of the week button, and then obviously we have the hours and the minutes button. A couple of things to remember about this timer. Always ensure that your clock is set to the current time. Just because your display shows the time does not mean that the heater is sensing 12 volts from the batteries. These timers come with their own batteries, rechargeable batteries. They have a 5-year lifespan and they're rechargeable. So just because you see the display does not indicate power to the heater. Make sure that the day of the week indicator, and you'll see that on the slide, is pointing to the current day of the week. Otherwise, all your programming will result in a miscalculation. The day of the week starts with number 1 all the way up to 7, and number 1 indicates Monday. Usually you would think it would indicate a Sunday, but in this case it starts with a Monday, so please remember that. As I mentioned before, every heater on event has to have an off event also for the timer to work correctly. Once you have programmed the events for the events to be executed automatically, make sure that the function switch is set to the 1 position, that's the center position, and make sure that mode switch is set to the auto position, which again is the center position. If those switches are in any other position, then your programmed events will not work. We move on to the next slide, and this slide shows the electrical schematic. And here you see the wiring diagram, and you can see the connection into the heater. This is for the D5E heater, and you can see it has a 10-pin connector that plugs into the heater. And from there are a couple of leads or a couple of branches basically going up to the battery, direct to the battery. We have a harness that goes up to your fuel metering pump. We have a harness that goes up to your control unit. On this slide, we have shown the programmable timer, but it could be your Multimax F1000 also. And then we have an electrical lead that goes up to your water pump. We also have a diagnostic connector to enable diagnostics, and we're going to talk a little bit about diagnostics later on in this webinar. All of this information that you see on these slides have been drawn from the manual. So if you download our manuals, they'll have detailed schematics on the heater as well as the wiring harnesses. We move on to the next slide, and this is where we're talking about the parts of the heater. For those of you who have worked on any heaters before, you'll find that most of the core principal parts remain the same. So if you look at the heater, it does come with a water pump. It's an externally mounted water pump, which has a delivery rate of 3 gallons a minute. The heater requires about 1.1 gallons per minute, so the water pump is strong enough to deliver or do the job. It comes with an electrical motor, which serves the function of drawing in the combustion air into your combustion chamber. There's a control box or an ECU that monitors the heater right from the time you start the heater till the time you stop the heater. The combustion air fan draws combustion air into the combustion chamber. And then we have sensors. We have what's called as a surface sensor. We have an overheating and a coolant temperature sensor and a flame sensor. In this particular model of the heater, the overheating sensor and the coolant temperature sensor are combined into one part. We do also have a surface sensor which measures the temperature of the heater outside on the water jacket. And the purpose of measuring the surface sensor or surface temperature is to monitor the flow rate. So the difference between the surface sensor and the overheating sensor will actually give us a clue as to what the flow rate is going on in the heater. When we talk about the coolant pump is a magnetic pump. And the chances are, if you have contamination in the coolant, these contaminants can get accumulated in the water pump assembly and slow the pump down. When the pump slows down, you have less coolant flowing through the heater. As a result, the temperatures will go up. And then the heater can do two things. One is it can cycle down quickly, and thereby you don't get all the BTUs that you're supposed to get. And number two is, if the temperatures go higher, then your heater will overheat and quickly shut down. So if that happens, then we need to go in and make sure that we can service the pump and clean the pump and increase the flow rate. If it is due to a valve being closed, we got to make sure that the valves are open. If it's due to a kink in the coolant hoses, make sure that the coolant hoses are laid out correctly. So we have the surface sensor, the overheating, and the coolant temperature sensor, the flame sensor. There's a separate view of the flame sensor on the far right hand of the slide. And the flame sensor basically does the job of detecting the flame as the fuel ignites. It does so by measuring the temperature of the exhaust. So when you have a fuel which is burning, the exhaust that comes out from the flame tube has to go out through the exhaust system. But before it does, it has to pass over the sensor. We do have the combustion chamber, which basically where you have the fuel and air being mixed and ignited by the glow pin. The glow pin does the job of igniting the mixture. We talked about the fuel metering pump earlier. It delivers the fuel into the combustion chamber, and then we have the coolant pump assembly. Moving on to the next slide. This slide actually shows us the cycling temperatures of this heater. When you look at this graph, it tells you that when you start the heater, it always starts up in the full power mode. And when you look at the graph, one of the things that stands out again is the number of heating modes. It has 3 heating modes. You have a power mode, a high mode, and a low mode. When you start the heater, it starts in power, and once the temperature of the coolant reaches 149 degrees, that's when it switches from power to high. And then it remains in that state until it reaches 176 degrees. And when it reaches 176 degrees, the heater switches from high to low. Now, each of the stages, you're looking at a reduced amount of BTUs. Now, between the power stage and the high stage, the difference in BTU is not too much. In the power stage, you're looking at about 17,700 BTU, and in the high stage, you're looking close to 17,000 BTU. But when it switches from the power stage, from the high stage to the low stage, that's when you're going to see a drastic change in the BTU. Your BTU drops almost by half, so you're looking at about 8,000 BTU roughly. So if you have a heater that comes on, stays on for a couple of minutes in power, another couple of minutes in high, and then quickly drops down to low, and then gives you only half the BTU output, that's when you'll start seeing issues in the field where the drivers will say, my heater's not giving us enough heat. So what you have to do is you have to monitor the flow rate of the coolant. One of the easiest ways to monitor the flow rate of the heater, of the coolant flowing through the heater, is to measure the temperature at the inlet and the outlet hoses coming from the heater. You run the heater for about 10 minutes and measure the temperature. The temperature difference should not be more than 18 degrees Fahrenheit after the heater has run for about 10 minutes. If the temperature difference exceeds 18 degrees Fahrenheit, that means you have a flow issue. The heater does not stop at that point in time. It continues to operate. When that temperature difference goes up to more than 48 degrees Fahrenheit, that's when the heater will stop and give you a fault code 14. So you can see in the graph, once the heater has switched from high to low, if the temperature within the heater does not fall, instead it keeps continuing to rise at about 185 degrees, the heater is programmed to switch off. So that's a safety feature inbuilt into every heater. And when it switches off, it basically does what's called a 90-second after run or cool down cycle. And then in that mode, only your water pump would operate. Every other component is switched off. Your fan would be switched off. Your glow pin would be switched off. Your fuel metering pump would be switched off. But your water pump or the coolant pump will still continue to operate, pushing the coolant around the sensors. When those sensors detect a drop in temperature up to 167 degrees, that's when the heater is automatically restarted. We move on to the next slide, and here we talk about heater safety features and fault codes. A lot of safety features inbuilt into the within 70 seconds after being switched on, the start attempt is repeated. So this is pre-programmed into the ECU. So you have to push the button only once, or your timer has to start the heater only once. And if within 70 seconds after the fuel metering pump is activated, if there's no ignition, the heater will make a second attempt. The heater makes a total of 3 attempts all in all in a period of 240 seconds. So there are multiple attempts made by the heater. In the normal conditions, the heater will start up in the very first attempt. But these additional 2 attempts are meant as basically a precaution, as an assist, especially when it starts getting colder. Now, in spite of making 3 attempts, if it still does not ignite a flame, then the heater is programmed to shut down and go through what's called as a cool-down cycle. The cool-down cycle will last approximately about 3 minutes, but it will log a code 52 in the memory. Now, if your heater comes up with a fault code 52 while you're trying to start, what do you need to check? There are a couple of basic checks that you need to do in case of code 52. One is, it could be because of lack of fuel. To check for fuel in the tanks. It could be because of air bubbles in the fuel line. To check the connectors for any kind of air leaks. Make sure your jams are tight and secure. Check for any restrictions in the exhaust. If your exhaust is damaged or crushed, that could be the reason why your heater is not able to start up. The fuel metering pump has to be securely mounted, and it has to deliver the exact amount of fuel. To make sure it's at the right angle with the pressure side of the pump, which is the electrical connection side, is always on the top. Sometimes the heater may have a code 52 because it has excessive carbon or excessive fuel in the combustion chamber. When you have a code 52, the heater stops after going through the cool-down cycle. You always have an option to restart it. So if you're a driver sitting in the bus, you can always push the button and try and restart the heater. But if the root cause of why the heater failed is not fixed, the heater is going to fail again and give us a code 52. In all of these attempts, what will happen is you may end up with a lot of fuel accumulation in the heater. So the advice to the driver should be, you should not try and start a heater more than twice. Because every time the driver tries, there is a 3-attempt process made by the heater if required to start an ignition. Let's move on to the next slide. Continuing with the heater safety features and fault codes, these heaters come with a safety lock. If your heater has code 52s happening frequently, after 10 failed start attempts, that means after 10 code 52s, the heater ECU is locked out automatically, and that will result in a code 50. So when your heater locks out, your driver cannot start the heater. He has to bring the bus back into the shop, and then the technician has to look at it and unlock the heater before he does anything else. Now, just unlocking the heater does not resolve the issue. So unlocking the heater is always the first step, but the most important step would be after that, that is to find and trace and fix the root cause. The lockout event, the lockout condition can happen because of 2 events. One is code 52 is happening multiple times, more than 10 times. The second condition would be if you have an overheating. Every time the heater has an overheating event, there is a log within the ECU that registers that event. And when that number reaches 10, the heater will automatically log out. And at that point in time, you're going to get code 15 in the ECU. So if you do have a locked out heater, you have to unlock it. So how do you unlock a locked out heater? By using diagnostic tools. We're going to talk about diagnostic tools later in the presentation. By using the diagnostic tools, all you have to do is clear the codes, clear the fault codes, and once you do that, your heater is unlocked and ready to go. But like I said before, the most important thing would be to find out what caused the problem. So just by saying, I had a heater locked out and I have unlocked it, does not mean a thing. You have to find out what caused the lockout. And that's why those codes are very important. If you have a code 50 that indicates the lockout, then the troubleshooting steps are different than if you have a code 15. Because because a code 52 usually is caused due to lack of fuel, lack of combustion air, or due to excessive carbon. The code 15, on the other hand, is an overheating code. It could be because of a restriction in the coolant flow. It could be because of air pockets in the coolant circuit. It could be because of a valve that's closed. Now, one important thing to note is if your ECU does get locked out and the heater does not run, then there's no other way to unlock it other than by using diagnostics. So you cannot unlock the heater by disconnecting the power supply. You have to use diagnostics. Now, before you clear the codes in the memory, ensure that you save those codes for future reference. Moving on to the next slide. Continuation of heater safety features and fault codes. Here we are talking about air pockets, as we mentioned before. Lack of fuel, air pockets in the fuel line. Lack of combustion air forced through the exhaust. All of this can cause the heater to lose flame during operation. It's always important to make sure you have a steady supply of fuel. Now, if the flame goes out due to any one of these reasons while the heater is in operation, then the heater automatically tries to restart. And when it restarts, if the restart attempt is successful, then there is no fault code logged in the memory. But if the event happens again within a span of 15 minutes, then you will get the code registered in the memory. So even if your heater loses flame, let's say you set it on a timer, start the heater in the morning at 5 a.m., and then you have this air bubble sitting in the fuel line that comes up to the heater, and the heater loses flame, it will restart. But if you have multiple air bubbles sitting in the fuel line, then it will not restart for the second time, and it will log the code and shut down. Once the heater shuts down because of a fault code, it can always be restarted either manually or by using the timer event function. Let's move on to the next slide. Now, in this slide we talk about overheating. In case of overheating, what happens? In case of overheating, the fuel pump, the heater shuts down, the fuel feed is interrupted, and then once you have determined what the cause of the overheating is, and you have fixed the problem, then you can restart the heater. The condition is that the heater should have sufficiently cooled down, and the temperature should be reading 158 or below. Only then would the heater start up. All of the heaters, whether it's a D5E heater that comes factory installed, or if it's a D5SC heater that's part of your aftermarket kit, all of these heaters, they come with a lower or upper voltage limit. It comes as a standard option inbuilt into the heater. On these heaters, so if the voltage goes below the low voltage threshold, then these heaters will stop operation. If your heater does not start up, or if your glow pin is defective, if there's an open circuit in the fuel steering pump harness, all of these conditions will cause the heater not to start up. The fan speed is important to the operation of the heater because it draws in the combustion air, and that's why it's continuously monitored. If the fan speed drops below 40% of the specified RPM speed, then the heater will shut down after a time period of 60 seconds. So whether it's low voltage or whether it's fan speed, the fault code will not be triggered almost instantaneously. There is a lapse or a delay. In case of a low voltage, the delay is set to 20 seconds. So the heater will monitor the voltage for 20 seconds to see is it below the lower threshold or not. And if it still continues to be below the low threshold, only then will it stop the heater. And the same rule applies to the fan speed as well. The fan speed has to stay below 40% of the nominal speed for more than 60 seconds for that fault code to be triggered. Let's move on to the next slide. What we are seeing over here on the slide is what to check first in case of fault. So as you can see listed, a couple of things. Number one is make sure there's fuel in the tank. We do have a standpipe that drops into the tank to draw fuel. Now, if you look at the installation, the standpipe does not touch the bottom of the tank. There's always a space of about 1.5 lose flame or it could have trouble starting up. Make sure your fuel pipes are not leaking, so you have to have this visual check at least once every season. Make sure that you have the right quality of fuel in the system. Make sure your combustion air system and the exhaust systems are not damaged or restricted in any way. You also have to check the electrical components. Make sure your cables and connections are not damaged. Make sure your contacts are not corroded. Make sure that your fuses are okay and you have the right wiring. Check the battery voltage. It has to be about 10 volts for the D5E unit to operate. If it is below 10 volts, then you are going to get a code 11, which is an under voltage potential. And the same rule applies to the upper threshold as well. The maximum voltage that the heater can withstand is 16 volts. Check the voltage supply at the 10-pin connector. So you do have the terminals 1 and 2. So make sure read the voltage there. If it differs from the battery voltage, check the fuses, the supply cables, ground connections, etc. The maximum voltage drop between the battery and what you sense at the heater should not be more than half a volt. And when the heater is in operation, if that maximum drop can go up to 1 volt, but never more than that. Move on to the next slide. Here what we see is the diagnostic tool options. Now some of you may already have this in place. It's important to have the diagnostic tools because as you know, if the heater does lock out, let's say for overheating events or because of failure to start events, you would need it to unlock the heater. So we have two basic options listed. We have what's the e-diagnostic unit, which is on the left-hand side of the slide, and then we have EDIT. The e-diagnostic unit is nothing but a basic code reader, and what it does is it plugs into the heater and you read the codes off the memory of the heater, as simple as that. It's a great little device. It's portable, does not require computer or software, and so it's very versatile. The only drawback to the device is you got to wait for a fault event to happen before you can actually read it. So it does not allow you to do any kind of predictive maintenance or preventative maintenance on the heater. The EDIT software, on the other hand, is a much more comprehensive software. EDIT, by the way, stands for Espar Diagnostic Tool for Heaters. It's an acronym. Espar is the name of the company that makes these heaters. So this software is available for a free download as a free download on our website. We do have a new website right now, and the manuals and diagnostic software are all in the secure portion of the website. You would definitely need a login and a password to access it, but the good news is you can always get it just by doing a simple registration process. So if you go onto a website and click on that link, it'll ask you to register, and once you have registered, you get access to the secure content, which includes the software installation as well. Listed at the bottom of the slide is what's called as an EDIT ISO adapter. What you're seeing right there is the hardware part of it. You'll have to purchase that. It's basically a translator that allows the heater and the computer to talk to each other. It's not a diagnostic tool. When you order that part number, you get the box, the cables, and everything that's needed to fit in the system. Let's move on to the next slide. Here we're talking about adapters and tools. So to make a final connection into the heater, we do need additional adapters. What I've shown over here is the D5E adapter. We do have another adapter. I've not shown it on this slide, and that will be required for the aftermarket kits, which has the D5S heater at this point in time. So it's a separate part number and a separate, it looks different because the connectors on both these heaters are different. We do have terminal release tools. Now, one word about these terminal release tools, they're extremely important to have them. Now, you may order these tools directly through us. You may order directly through the supplier. These are third-party tools. Or you could have if you don't have these tools? Well, obviously your repair and service time is going to increase, number one, and worse, you're going to cause damage to the terminals. If you damage those terminals attached to the components, for example, if you damage the terminals attached to the blower motor, you end up having to buy the whole blower motor again because those terminals are not available as a spare part. You may try and attempt to use off-the-shelf terminals, but in that case, your heater is going to give you issues because it won't have a secure connection and it's bound to fail sooner or later. Having these tools are very important, and you have a choice to select it or buy it directly from us or through any source. Make sure that you have the right size part available. We move on to the next slide. This shows the diagnostic connections on the heater. Again, this is for the D5E heater, which comes factory installed. And as you can see, the diagnostic connector is in the box, so you'll have to open the lid of the box to get into the connector. And once you have that, using the adapter, it's a very simple plug-and-play connection. So you start off from the heater end, you connect to the heater first. From the heater, then you connect the ISO adapter, and the final connection you would connect to the computer having the EDIT software. If you don't have EDIT software, if you're going to use the diagnostic unit, again, the procedure would be the same, except for the computer, they want to use the e-diagnostic unit in the place of the computer with the EDIT software. Next slide, please. What you see over here is the EDIT diagnostic testing process. When you go into EDIT, when you start up the software, there are some few basic steps that you need to do to get the whole process started. I've shown this on the slide, or attempted to show it on the slide by indicating the numbers. So number one would be to click on that, those two, that icon on the menu bar. To click on that, it opens up the heater and test selection window. Once the heater and test selection window is opened up, then the next thing, number two step, would be to select the right group of heaters. For all factory installed heaters, you're going to select Hydronic 2 family of heaters. If it's an aftermarket installed heater, then you got to select the group that's just about the one that is shown on the slide, which is the Hydronic B/D 4/5 WSC heater family. Once you've selected the right group in the left-hand column, the next column gives you a selection of the model number. Every style of heater will come with a unique model number. So you have two ways of doing it. You can either manually go and select the model number, or you could do an automatic detection. So number three step would be to click on automatic detection. Number four would be to confirm that you would like to do an automatic detection. And then once you do that, your heater model number will be automatically selected, and you will get the list of tests that you're able to do in the extreme right-hand column. And you have three tests listed. You have a general data test, you have a function test, and you have a switch-on component test. Each of these tests are important. If you're going to use diagnostic, I would definitely recommend you start with the general data test. And that's the content on the next slide. So let's move on to the next slide, please. So what you see over here is a snapshot of the general data test. And as you can see, it's done on a D5E heater, and it gives you two windows. So the top window is showing us the fault codes along with the active fault code. And in this particular case, you can see that the active fault, AF, has a 0 in front, which means there are no faults in the memory at this point in time. So there are no active faults present. Below that, you have codes F1 to F5 memory locations. And against each of those, you have all of them as zeros except for F1, which shows code 42, which means previously, sometime in the past, it had a water pump short circuit issue. Now, as you can tell, by looking at the fault code window, you're able to tell, was there a failure event that happened in the past? But it does not give you the time, the date and time. If you're going to use a multi-max switch, the event log in the SD card will be saving that information for you. So it kind of helps you understand when did this glow pin activations. It gives you information on the overheating counter, the safety time counter, and the number of times the flame cut out. There's information like not only the operational hours, but also gives you the hours in each heater stage or heat stage. And that's important to understand because I could have two heaters that have run for 1,000 hours each, but the first one could have cycled between all of those stages equally, almost equally, and then you could have the second heater that seemed to have cycled more in the low stage, which will lead us to believe that there is a problem in the installation or in the operation of the heater because the heater seems to be cycling and remaining in the low mode for quite longer than it should. If you look closely into the slide, you will see, and in the bottom window there's a label that says adjustment mode, and it shows 41 minutes against it. That adjustment is basically the time when the heater switches off with only the water pump running. And why does the heater switch off? If you go back to the slide that showed the temperature cycling, when the temperature of the water or the coolant rises above 185 degrees, that's when the heater switches off. So for 41 minutes, the temperature of the water was about 185 minutes. That's what it indicates. It shows us information on the fuel consumption. It shows us information on the atmospheric pressure that's being measured. If you attach an atmospheric sensor, it will measure the pressure and it will give us a readout. It will also tell us how long it has operated in elevations above 5,000 feet. And at the bottom, you have, again, additional information. You're seeing the flame cutout, loss of flame events, how many times it lost flame in high heat mode, the power mode, as well as your low mode. And then finally, towards the very bottom, you have the number of repeat starts. All of this information gives us a good insight into the past operation of the heater, and it's a good basis to start. And that's why I always recommend you start with this test every time you do diagnostics. Let's move on to the next slide. The next slide actually shows us the function test, and what you're seeing over here is the operation of the heater right from 0 seconds till the time you stop it. And it basically gives you all of the activities in the heater. It tells you which component is active, which component is deactivated. It talks about the speed, gives you the speed, gives you the voltages, the frequencies, etc. It gives you the temperatures of the sensors. So it gives you temperature of the flame sensor, temperature of the control sensor, temperature of the surface sensor, etc. It tells you if it's making an initial start. And as you go back in the past couple of slides, we talked about start attempts, and we said there's a maximum of 3 attempts. So whether it's making an initial start attempt or is it making a repeat start attempt, if the heater has cycled down and gone into what's called as a standby mode because your water temperature is already about 185, then the temperature drops to 167, the heater automatically restarts, and in that case, it will show us that it's making a controlled restart. It also gives us information on the battery voltage that it's being sensed by the heater at the heater. So lots of useful information which helps us to understand totally what's happening. It gives us temperatures, frequencies, speeds, voltages, etc. And using this information, you can predict failure events that may happen in the future. But in order to do that, you need to have a base to start. And that is why when you are doing diagnostics on a brand new heater, I would definitely recommend you run diagnostics, save the file, and use that as your base or reference point. Because when you look at a heater 2 years from now, if the heater does not give us the same information as it operates, that means we can then jump into it and basically, determine if there's a problem. So function test is a really useful test. The next slide, let's move on to the next slide, which again shows us the part of the function test. It's a slightly different. And here in this slide, you can see initially the glow pin was activated, and now in this slide, you're seeing the glow pin is now not activated. That means it's been switched off. Excuse me. the things that you got to remember is the glow pin does not remain on all the time. It remains on only for the first couple of minutes, maybe a minute, minute and a half initially, just to ignite the flame, as long as to ignite the flame. Once the flame is ignited, after a lapse of about 60 seconds, the glow pin will be switched off. When the glow pin is activated, you may see that the amp draw of a glow pin will be around 7 or 8 amps. But after that, it will drop down to almost 3 amps. So here we are seeing the glow pin has been deactivated. The fan motor is still continuing to operate. The fuel metering pump is operating at a much higher frequency of 6 times per second. And as a result of all this activity, you can see the temperature starting to rise. And the heater is now in the high control or the power control stage at this point in time. When the temperature goes to those values that we talked about before in the slide, the heater is going to cycle between those 3 different stages, which is power, high, and low. If the temperature goes beyond 185, it's going to go into standby mode or the controlled off stage. So let's move on to the next slide. Here we're talking about annual pre-season maintenance. There are 3 most important maintenance recommendations. We already talked about the first one way back. That is, run the heater at least for 15 minutes every month of the year. Plain and simple, it takes away most of the issues that you may otherwise have. The next important thing that you got to do is the visual inspection. As part of the visual inspection, you got to check the heater. You got to check the electrical harnesses, the fuel metering pump angles, the coolant hoses. Look for any kind of coolant leaks. Make sure your exhaust connections are good, fuel lines are good. Measure the flow rate. Measure the temperature difference between the in and the out coming from the heater. As I mentioned before, the temperature difference should not be more than 18 degrees after 10 minutes of operation. Inspect the fuel filter on the suction end of the pump and replace it if it is necessary. And the third most important maintenance recommendation would be to download and review the fault codes in the heater, including the operational hours, the overheat counter, etc. All of this information gives us a status on the heater. Is it performing as it should? Is it running as much as it should? Based on a programmed event, if you do the math, whatever hours you program each day, that should total up towards the end of the year, and that's what you should see in the heater. That's number one. Number two is, although the heater may total up to the total number of hours, the cycling of the heater should be in the heating range, whether it's in power, whether it's in high, whether it's in low. And we got to look into that and see, is it giving us maximum BTU all the time, or is it dropping down and giving us half of the BTUs, or in some extreme cases, is it not giving us any BTU at all and just operating the water pump? Moving on to the next slide. Here we talk about testing voltages, and this is very important. The heaters are rated for 12 volts, but that does not mean that your components, all of the components are rated for 12 volts. A case in point is the blower motor and your glow pin. These 2 components have a much lower voltage rating. So if you're going to test the blower motor, you cannot apply more than 8.2 volts on the blower motor. The same deals with the glow pin. If you want to check the glow pin, you cannot apply more than 9.5 volts. If you do apply 12 volts to any one of these components, you can cause damage to the components, and that could be the reason for failure. Now, you may have a question which says, I don't have 8 volts in my shop or 9.5 volts or variable voltage supply in my shop. What do I do? You can use the switch-on component test in EDIC. The diagnostic software allows you to independently start the components, and that's how you can do the testing of the components. And that's the best way to do the testing of the components, even without the need for removing the components from the heater. Let's move on to the next slide. Here we continue with the testing of the components. The other best way to test components would be to measure the resistance. So here they've shown us the temperature and the overheat sensor. stage would be downloading the codes and reviewing the heater data. And then once you have enough proof that there is a problem with the component, that's when you would tear down and then do further testing of the independent components. Let's move on to the next slide. We already talked about coolant flow, and we talked about any restriction can cause the heater to either cycle down or overheat quickly. Now, on the buses, you have a temperature control knob, and this will directly affect the temperature output of the heater. So make sure that these temperature control knobs, they are set to the full hot position before the bus is switched off in order to function correctly. So they are electronically controlled. If you turn the knob later, it may not open the valve, which means if the heater is set on a timer, it's going to come on because of the restriction. It's going to overheat. And the problem is not only would the heater shut down, but because when it overheats, every time it overheats, the temperature goes straight through the roof in the heater and causes damage to the components. So if you have a heater that's subjected every other day to an overheating event, you can be sure that that heater will have component damage, and the most, the damage will start from components like the O-ring. So now you start seeing coolant leaks, and if you don't fix that or address that, it may lead to other complications like corrosion damage and component damage, etc. Let's move on to the next slide, please. So this is again an add-on to the previous slide. So we have the standard heater cutoff valve. They have shown us a different diagram for different kinds of buses where the valves are located. So make sure all the cutoff valves are open before the heater is operated. And this is very important, particularly in school buses, because we've seen a lot of issues that may happen if they try and operate the heaters with closed valves. I guess we are almost towards the end of the presentation. The next slide, please. Espar.com. That's the website. And as I mentioned before, it's a totally revamped website. We are still in the middle of a transition stage right now. We have lots of useful information over there. We have videos. We have links to the manual. We have dealer locations, etc., etc., etc. We have a parts lookup. So lots of useful information. If you do need manuals or software, there's a secure portion within the website that you'll be able to get access to after you have registered yourself. Before, this was not, there was no registration process. With a new website, we do have a registration process. It's quick and simple. If you do need assistance, feel free to call us. There is a contact number that will be coming up shortly. You should be able to call us, and then we'll be able to gladly help you with any issues that you may have. Let's move on to the next slide, the heater manual. The slide shows the heater manual. That's your Bible. That's your main source of reference for any heater. All heaters have a manual. It's a comprehensive manual, shows the heater, components within the heater, the installation guidelines, the operational guidelines, the schematics, the fault codes, the different configurations of plumbing, etc., etc. Download these manuals from the website and use it as your source, number one source, before you do any troubleshooting and service on any heater. Next slide, please. Warranty. 3 simple rules on warranty. We have an always repair policy, so do not replace whole heaters. If you do have a heater problem, first find out what the problem is. Is it because of component, or is it something external to the heater? It could be, for all you know, a weak battery that may not be causing the heater to operate. If you do have to remove parts, do not damage the parts, so you should not be trying to cut the cables or break any parts. The best recommendation would be, if you do remove the parts, try to package them in the same packaging that the replacement parts came in, so that way it gets protected even during shipping. And then finally, number 3 is the most important, is that describe the test that you do. Make sure you mention all the results, the fault codes, the liter hours. All of this that would be hosted on our website and saying that this line is active and you can call in. We do have an email of all our personnel up on the website. If you do have any comments or suggestions on this webinar, you do have my email address below. So in case you feel the need for, let's say, further on-site training, comprehensive training, feel free to send me an email. I'll be more than happy to respond. So having said that, I think we move on to the last slide, the question slides, and more than happy to accept any questions from your side, please. Gina?
All right. Thank you very much, George. Does anyone out there have any questions at this time? George, I do have one. Is all of the product with the new inertia switch, is that a running change right now, or is all current product being produced with the new inertia switch?
As far as I understand it, the new products, basically they're introducing it. I've been told that they have recently released it as far as the aftermarket kit goes.
Okay.
I have an exact cutoff date with me, but if you need, I can find that from our engineering group.
Okay, yeah, I'd be interested to know if it's a running change and there's still product being produced with the old, or if all product currently being produced is with the new inertia switch. That would be interesting to know.
Okay.
Yeah.
I'll get that information back to you.
Okay, great. Yeah. And is there any other questions out there? All right. Well, thank you very much, everyone, for attending this afternoon. And George, certainly do appreciate you. You always do a wonderful job for us, and appreciate your time. And we'll talk to you here in a couple hours. Everyone, have a great day.